students, I am Dr. Nilesh Savan from Savan Science Academy, and we are back with a new lecture on the topic Basic Principles of Organic Chemistry. So in the last three lectures, we have seen the first two lectures, the last of the three lectures, we have seen the IUPAC naming, rules for the IUPAC naming, how to name the substituents and the complex substituents, and in the very last video, we have seen how to give the common names. So today we will try to name at least majority of the alkanes, that is up to 5 to 6 carbon alkanes with common names of the organic compounds whose common names are possible, and IUPAC names of course. So we'll start with this. So we'll start with the first carbon onwards. So we'll start with first carbon compound, that is methane. So obviously its IUPAC name will be given as methane, obviously. Next, two carbon compounds CH3 and CH3. This will be written as ethane. Remember, common naming starts from 3 or more than 3 carbons in the chain, organic chain. So these two are quite simple. How to write propane CH3, CH2, CH3. Now in case of alkanes, so here we are exclusively seeing alkanes only. We are not going to deal with the functional groups yet. In the next video, we'll start with the functional groups. How to name a functional group. What are the prefixes? Primary prefix, secondary prefix, then root chain, then secondary suffix, primary suffix. How to write it. We'll see that in detail when we start with the functional groups. So today I'll be taking only examples which is concerned with alkanes. So here this one, 3 carbon chain, obviously we call it as propane. No common name yet till here. Next, for 4 carbon we can write a 4 carbon hydrocarbon. We can arrange in 2 ways. So if you see, this is the first way. Now it is more than 3, so 4 carbon compound, we call it as butane. So if IUPAC name is asked, we will simply write butane. But common name, if they are asking you, so you have to write this as N. N means normal, straight, and this is N-butane. So in common naming, this will be termed as N-butane, and IUPAC will simply call it as butane. Next one more organic structure is possible when the chain is compound consists of 4 carbon is this one. So while naming the IUPAC name, we will see the the longest chain in that. So we have a 3 carbon. You can go from this side also because it is in middle only. So I can take this 1 2 3 or 1 2 3. It's one and the same because from both sides the branch is getting the same number. So it is irrelevant whether I start from here or from here in this case. So when we write the IUPAC name, so simple locant of the branch, this is the substituent, simple substituent. So the locant of the substituent is written first, hyphen to separate that, and obviously the first letter is capital methyl, and then the all other letters are small. Longest chain is of propane, so the name goes as 2-methyl propane. And if I want to write the common name, so in that we have studied iso. Iso is a prefix when we give to a organic compound where except 1 carbon all are in straight chain. So here you can see 3 carbons are in straight chain, only 1 is in branch, which is the second. So total number of carbons in and in common name we generally use total number of carbons. So what we write over here, this will be called as, this is the iso group because methyl group is attached to the second carbon. So this will be written as isobutane. Okay. So whenever we write this name, when we write iso, that means out of the butane 1 carbon is in a branch manner or in discontinuous manner, where other 3 are in straight chain. So this is the common name for this. So this will be the common name for this structures. Next we'll see pentanes and the isomers of pentanes. So the simplest of all isomers is CH3, this one. So IUPAC name, if I want to write over here, it will go simple as 5 carbon, so capital letter first, and this is pentane. But if I want to write the common name, okay, so just put the prefix N because it's a straight one, and obviously we'll write it as pentane. Okay, so hope so you're getting this. So these are the simple names, and I'm also giving their common namings also here. So this is pentane and this is N-pentane. So we'll see an isomer of that. Suppose this is the structure of its isomer. So इसका नाम क्या होगा? So first we'll give the IUPAC name, and IUPAC, as it suggests, you can see at the second. First we'll see the longest chain. So in this longest chain is surely this 1, 2, 3, 4. And now I have started from this side because the branch, that is the substituent, should get the least number. So by going by this side, it will get the least. If I go from that side, it will get the locant as 3. From here, it will get the locant as 2. So simple sa logic hai. The rule number 2, which it says, first to follow the longest or find the longest chain, which is over there. Next is number the chain such that the substituent should get the least number. ठीक है, so simple सा फंडा यूज करो. ब्रांचिंग जहां से शुरू हो रही है लोएस्ट नंबर पे, that should be the side of the longest chain. तो इधर से तो 3 पे, इधर से 2 पे, so go from this side. ठीक है, so इसका नाम क्या आएगा? So what will be the name of this? So here I am writing the locant to the branch, that is methyl, and the longest chain in that is butane. So this will be written as 2-methyl butane. Whereas if we try to give a common name to this, so here also you can see out of the you can see total number of carbons are 5, out of which 4 are straight, 1 is in branch. So this constitutes for iso. Remember, whenever methyl is attached to second, only one branch in the entire chain, that is at the second carbon, it is termed as iso. CH3 CH CH3 दिख रहा है. So CN, that is the common naming of this, will be iso. This will be pentane. The total number of carbon is 5, so the name goes as isopentane. One more isomer, I'll just rub this off now, so you can follow along with me for these names. So one more isomer of pentane, which can be written in this way: CH3, CCH3, CCH3, CCH3. So here you can see this. In this, first we'll try to give the IUPAC name. So in this, it is quite clear. The longest chain I can take either as this, as 3, or I can go this way, horizontally 3. So I will go in this way. So second is to number the chain. So from any side you go, the branches are getting the same number. Even if I go from this side 2, 2, even from this side 2, 2. So say 1, 2 and 3. So the name goes as 2, 2. So what the fourth rule says, if the same substituent is present more than once or 2 or more times, so we'll use the prefixes. Okay? So for 2 methyls we are using the prefix di. So this is the first letter, it should come as capital. Then it should be dimethyl. And the longest carbon is of 3, carbon chain is of 3, so it is dimethyl propane. But common name, what does it say? So this is for neo. What does neo says? Out of the total number of carbons, 2 are as a branch, while rest of it is in continuous form. So out of the 5, 2 are in branch and they are attached to the second carbon only. For constituting it as neo in a common naming, the branches, the 2 methyl branches should be at the second carbon only. So from here you can see, so the common name will be neopentane of these group. Okay, so these are the IUPAC name of the isomers of the first 5 or other first 5 alkanes. Okay, the names and the IUPAC name and common names of these compounds. Generally for boards, when you are studying for boards, generally till here only the reactions are asked up to 5 to 6 carbon. They don't ask any chemical reaction beyond 6 to 7 carbon compound, because then it will be too hectic also. But these smaller compounds will have the common names. Now beyond this, the common names goes a bit difficult, because as the complexity increases, the common name fails. That's why we only use IUPAC name. Okay? So till here, I hope so सबको समझा है. I'll take one more example of hexane, and then we'll see others with other examples where we have complex substituents. Okay? And in that also we'll see few rules. Okay? Or explained over there. So let's see of hexane. So one of the isomer of hexane we already know is the straight one. So this is CH3, CH2, CH2, CH3. So this will be written as, in case of IUPAC, it is straightforward written as hexane. In common naming, it is just written as N-hexane, where N stands for straight. Now if I take one carbon as a branch, like this say, so this is the case. So here you can see it again, we have a CH3, CH, CH3 group. So this is iso. So ये common naming में आता है. हम अगर IUPAC name देखें, if we first see IUPAC naming, again we'll see the longest chain over here. So obviously we start numbering from that end where the branch gets the least number. So 2. So again the name goes as 2-methyl, and the longest chain is of 5. So we'll write this as pentane. What's the common name of this? It is simple, isohexane. So this can be called as isohexane. Say a new structure, say CH3, CH2. Let's say the branch is over here, CH2 and CH3. So if this was here also, still the name would be the same, isohexane, because then this is the second carbon and that second carbon would have a branch. So suppose this is one of the structures. So what would be the IUPAC naming? So again go for the longest chain. So this is the probable longest chain, because if you start from here 1, 2, 3, 4, 1, 2, 3, 4, this is at least 5. So we'll start naming. Now even if you start naming from this side 1, 2, 3, 1, 2, 3, so the numbering doesn't matter, because the substituent is getting the same number from either sides, and that is the third one. Okay? So 1, 2, 3, 4, 5. So I'll just number it. Now how to write it? So 3, the locant, hyphen to separate it with the name, it's 3-methyl, and obviously the parent chain is pentane. So this is its IUPAC name. Now remember, this doesn't have any common name. That's why we are not using common name mostly, because it fails when the carbon number reaches 5 or 6 carbons or more. Okay? So we'll just give the IUPAC now names henceforth now. So if this is one of the example of 6 carbon compound, say this is the question. Chalo, give the IUPAC name for this. Give the IUPAC name for this. So again we'll follow the steps. First, select the longest chain. So this is the longest chain. Second step, number the chain such that branches should get the least number. So 1, 2, 3 and 4, or 1, 2, 3 and 4 would do the same job over here. So the name goes as 2, 3 dimethyl. 2, 3 dimethyl butane. So this will be, and again no common name over here. Okay? Because in case of iso, it says that only one carbon is in branch while other are in continuous chain. Here there are 2 branches, so you can't write it as iso over here. So this is the only IUPAC name, no common name in this case. Okay? And one more question to go. So suppose this is the question. I can write these 6 carbons in this way too. So what would be the name over here? So again, longest chain is straight. You can even go this way, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. But I'll choose the most easiest one so that the naming becomes easy. So simple. from which end should I start? The simple rule number 2, we should start from that end where the substituents get the least number. So 1, 2, 3 and 4. So what would be the IUPAC name in this case? It will be 2, 2. The same locant has 2 branches, so you have to repeat the locant number. Locant means the number that we give to the carbons in the longest chain is called as locants. So the number, it should be repeated if that same number has 2 branches. So 2, 2, obviously we use the prefix dimethyl, and the longest chain here would be butane. But this has a common name because others are in straight chain, only 2 methyl groups, and that too they are attached on the second carbon of the chain. So this makes the branch that is called as neo, and total number of carbons are 4 plus 2, that gives us 6. So this is the structure of neohexane. So hope so till 6 carbons I have explained each and every structure, and I have given its IUPAC name and also its common name. For boards, this much is enough. For even entrances, when they are asking some reactions, till this it's enough, almost enough. Now only thing what we have to see is some bigger alkanes, and those examples generally come for IUPAC name. So we'll see that. So if you just understood how to name and give IUPAC in common names till here, you will be, you can say, the most of the issues are sorted for you. Okay? In case of reactions wise, okay? Because they generally don't ask a chemical reaction with a decane or a no name of that sort. So generally what they use is this only. So you should be aware of these IUPAC name common names because these are the most frequently used questions. Okay? But when we want to see IUPAC name, so we'll see some difficult part of it. So we'll see some difficult questions with more branching and complex. So now these will not have common names, so I'll just make sure that these are larger alkanes and some with complex substitute. Let's see this: 1, 2, 3, 4, 5 and 6 and 7. Okay? So suppose at one of its end this is the branch, and at one of the carbon this is the branch. So I'll just go in details with some of the rules which generally students find it difficult. So I'll start with this. Okay? So what should be the name of this? So here, look over here. First find the longest chain. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So if you see 1, 2, 3, 4, 5, 6. So if you go look around, you will find the longest chain as a chain of 7 carbon atoms. So this should be the chain. Now, from which end we should number? So I told you such that the branching should get the least number. If I go from this side, the branching starts at 4. If I go from this side, the branching starts at 3. Sometimes when there are multiple branches, sometimes you might get confused from where to start. So that time you can use the lowest locant rule. Means simple है कि branching जहाँ से start हो रही, that should be the end from where you should start numbering. But if you don't find it conducive, then go for the lowest locant rule. Still it would work the same. So if suppose I want to number it from this side, tell me on which locants or which carbon of the parent chain the branches are attached. I am not bothered which branches are attached. I am asking you on which carbon the substituents are attached. So if you see third and fourth, so from this side 3 and 4, so the total of these locants is 7. Suppose if I say I want to number from this side, so on which locant numbers are the substituents present? 1, 2, 3, 4 and 5. So here the locant numbers are 4 and 5, which sums up to 9. So see from which end you are getting the lowest number. This side. So this should be the side from which you should number the chain. So obviously this is 1, 2, 3 and 4, 5, 6 and 7. Next step. Now the third rule says you have to write the substituents first and then the parent chain. Now just have a look before we start writing. Just look over here. I'm just naming those substituents. Now look over here. This is a simple substituent which is methyl, and this it is at the third. And if I see over here, now here I will be also using the iso-sec part in IUPAC name. But first we will give that genuine IUPAC name. So if this is a complex chain, here you can see 3 carbon complex substituent where the second carbon of that chain is joined to the parent chain. So in this case what we will do, the carbon which is attached to the root chain immediately is taken as first. Sometimes it is also written as 1-. So don't get confused if in the options you will find 1- over, because if it says you are numbering the parent chain as 1, 2, 3, 4, 5, 6, so the branched it should be written as 1-. So even if you don't give it, it won't matter, but sometimes in options they might write it in this way. So don't get confused with that. They might use this for, you can say, as a secondary branch, you can say in that way. So if you see this is the first, so the longest chain is of 2. You can take this also if you want, and hence the name of this compound would be 1-methyl 1-ethyl, or you can simply write ethyl, 1-methyl 1-ethyl. So if I see alphabetically, this is a simple substituent starting with M. This is a complex substituent which is starting with M. Okay? So obviously the complex one is preferred. So I will write in alphabetical order. Say 4, it should be 1-methyl ethyl. Then it should be written as 3-methyl. And the longest chain is heptane, So this should be the IUPAC name given to this compound. And if I want to write this as an, say, that common naming wise, so you can see, just look over here, the branch which is attached to the main chain, just leave this. So if you see, this is a propyl group where the second carbon is attached to the main parent chain. So if you look at CH3 is written as iso. So this branch can be written as isopropyl. Okay? So this can also be written as isopropyl. Now this is an important rule. Remember where. Now in IUPAC naming, it's given in the NCERTs clearly. You can use iso, neo, sec, third. You can use these prefixes, okay? But for alphabetical order, you have to consider this prefix also. Means if this prefix is, if you are using this prefix iso, then we are not going to see P. We are going to write it in alphabetical order, where I gets the preference in alphabetical order. Means you can use the alphabet of the prefix in the alphabetical order, but it is only applicable for these two. But if there is a branch, if there is a complex substituent with sec and third, okay, you need not use the alphabet in the alphabetical order. You have to use the alphabet of the alkyl group that is written. Suppose if it is sec butyl, so I will be using B over here in the alphabetical order, okay. But if it is iso, so I will be using I to see it whether it is in alphabetical order or not. So while writing into this, so for this groups, for branches, yaad rakho, iso, neo, they are taken in IUPAC naming, and here the alphabetical in the, while writing the name in alphabetical order, they are considered in the alphabetical order. Matlab these prefixes are considered in alphabetical order, but these two prefixes are not considered in alphabetical order. So if I just want to write the IUPAC name of this, so here also there is I and there is M, so that should be written first. So it should be 4-isopropyl 3-methyl heptane. So it can be written in this form also. So make note of this rule. Okay? Iso, neo, sec, third, you can use to name this, but in today's today's IUPAC, we mostly write in this manner. But a question may be asked in this, means the options may carry like iso, sec, tert as an options for IUPAC naming. So you should be aware of this. So iso and neo are okay with the IUPAC naming, and if such branches are there, then this prefix's first letter is used to put it in alphabetical order, but not for sec and tert. So the alkyl group which is considered joined to that, say sec butyl, then B will be the letter which will be considered in the alphabetical order. Hope so. This point is quite clear. That's why I've taken this example intentionally over here. Okay? So this rule application is quite important. Then one more rule to go with it. Now here if you see, the substituent and the complex substituent had the same alphabet. Okay? So I'll take one more example with this. Suppose CH3, CH2, C, CH3, H, C, H, C, H, C, CH3, 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 CH2 say, CH, CH3, CH2, CH2, and this would be CH3. Now just have a look over here. Now this is quite interesting also. Now here is one of the most important rule, and where many of the students go wrong. Now first we'll follow the rules. Simple as that. The rule number 1 is select the longest chain. So you look at that. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I think so this will be the only longest one. So 1, 2, 3, 4, 5, 6, 7. So you can have a look over there. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So you can see the longest chain is of 9 carbons. So it's a straightforward thing. This one. So the branches, you can see that potentially 3 branches which are joined over here. And of that you can see 2 are simple substitutes, whereas 1 is a complex one. So first we have selected the longest chain. Rule number 2, you have to number it so that the branches should get the least number. So if I start from here, 1, 2, 3, 4th carbon has a branch. 1, 2, 3, obviously third. So basically you can go from this side. If you still have a doubt, you can go for the lowest locant rule. See, write the locants where the branches are present. So if I go from this side, 3, 4, 5 and 6, means it is 3, 5 and 6 locants which have the branches. So if I total this, so it will come as 14. Let me go from this side. So 1, 2, 3, 4, 4, 5, 6, 7. So it is 4, 5 and 7. It is 4, 5 and 7. Okay? 4, 5 and 7. So it will make it 16, I think so. So you can see 14. So you should go from this side. Okay? So the second rule is also quite clear from where you should go. So if you find it difficult to gauge it, follow the lowest locant rule. वो भी necessary. नहीं तो simple rule है. Branching जहाँ से पहले शुरू होती है वही तुम्हारा side of naming. So we'll move on to the next rule. So obviously the number is also set 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay? Now look over here. When we are going to write, this will be written as methyl, but actually these two substituents are same, so they will be written collectively. So 3 and 6. So we'll be writing over here 3 and 6 dimethyl. Now remember, in case of simple substitutes, we don't use the prefix alphabet, means the first alphabet of prefix for what you can say, to write in alphabetical order. We use M of the alkyl group to write in alphabetical order for simple substitutes. Over here the name is 1,1-dimethyl ethyl. Now look over here, this is a complex substituent. In complex substituent, this is considered as a whole. Here only methyl is there, so simple, the prefix is not considered in alphabetical order, but this entire thing is one unit. So any alphabet which comes over here, let it be even if of the prefix also, this is considered in alphabetical order. So कॉम्प्लेक्स ब्रांच में m नहीं, हम मतलब जब कंपेयर, मतलब इसका जब तुम नंबरिंग दे रहे हो तो रेगुलर रूल्स फॉलो करो. अब जब तुम्हें नाम लिखना है तब किसका अल्फाबेटिकल ऑर्डर देखना है, तो वो देखने के लिए देखो, जब सिंपल सब्स्टिट्यूएंट्स होते हैं तो प्रीफिक्सेस आर नेवर रिटन, मींस द अल्फाबेट ऑफ द प्रीफिक्स इज नेवर कंसीडर्ड इन द अल्फाबेटिकल ऑर्डर. जो अल्किल ग्रुप का फर्स्ट लेटर है वो यूज होगा. बट इन कॉम्प्लेक्स जो हम पैरेंथेसिस में लिखते हैं, व्हिच यू राइट इन ब्रैकेट, any letter which is there in the first position, let it be of a prefix. Suppose it would be some trimethyl, so T would be taken for writing in the alphabetical order. ठीक है, से अगर 4 है तो टेट्रा, 5 है पेंटा, so P would be taken in alphabetical order. If here prefix was there, other prefix would be there. So the letter in a complex substituent which is at the first is always taken for the IUPAC. So from here you can say, here the letter to be seen is M and here the letter to be considered is D. So obviously this should be written first. So the name goes as 5 bracket, it is 1,1, then dimethyl ethyl, then the next two substituents 3,6-dimethyl, and the longest chain is nonane. So the longest chain would be nonane. So I think so everybody has got this. For simple substitutes, the alphabet of the prefix is never considered. We'll always look at the alphabet of the alkyl group over here. But in case of the complex substituent, the letter which is there in the first position, let it be of the prefix, still this is considered in the alphabetical order. Hope so you have got this rule. We'll see one more example to go with this. So if you want, you can also give a common name. Now this looks like a tertiary carbon attached to the main chain. So this is tertiary butyl. Okay, this is tertiary butyl and these are simple methyls. So when I said tertiary butyl, so I told you in the previous point, T is not considered in alphabetical order, we'll consider B, and those are dimethyls, in that we'll also consider M. So B comes first or M, so obviously B. So if I want to write the IUPAC name in terms of the complex substituent in the common naming sense, so इसका नाम आना चाहिए, so it should be 5-tert butyl. Next it would be 3,6-dimethyl nonane. So either of these can be written as the IUPAC naming for this compound. Hope so you're getting this. Okay, so for simple, so I'm again repeating, for simple substituents the alphabets of the prefix are of no use. We'll always use the alphabet of the alkyl group or the branch, simple branch, for alphabetical order naming. Whereas for complex substitute, the first alphabet in the parenthesis, let it be a prefix also, that is considered in the alphabetical order. If it matches, then obviously the next one will be considered. So we'll see one example of that too. So suppose one more example, then we'll see few examples of cycloalkanes also. We'll see few examples of cycloalkanes also. So let us take one last example, CH3, CH, CH2, CH2, say CH, 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 CH2, CH2, CH3, 1, 2, 3, 4, 5, 6, 7, 8, 9. You can go with one more also. Let's suppose 10, and this one suppose is CH, CH2, CH2, CH3. This would be CH2, CH2, CH2 and CH3, and let us say CH, CH3, CH3, and let this be C2H5. So it was a difficult वाला लिया है, so we'll try to solve this. Now suppose ऐसा question अगर आता है, so how we are going to approach this? So obviously first thing is, अब यहाँ पे काफी rules भी है. So first is you have to select the longest chain. So simple 1 2 3 4 5 6 7 8 9 10. Okay, 1 2 3 4 5 6 7 8 9 10. Okay, so everyone have a look at that too. Then 1 2 3 4 5 6 7 8. So this is not 1 2 3 4 5 6 7 8 9. 1 2 3 4 5 6 7 8 9. So here you can see there are two chains which are having 10 carbons. So rule number 1 का ही sub rule कि if there are two or more chains having same number of longest carbon chain, select that chain which will have maximum branches. So if I go in this way, suppose if I am taking this as the longest chain, so 1 2 and this is the third branch, okay? But if I go straight like this, so 1 2 3 and 4 branch, so it's better to go straight. Understood? So if first we have to select the longest chain. Now in that quest we are encountering two longest chains because both have 10 carbons each. So sub rule of that key, if there are two or more chains having the same number of carbon atoms in the longest chain, choose that one which will have maximum substituents. So this is what I have chosen. Rule number 2 is, now this is also is having a sub rule over here. See, simple hai, you have to number from that end so that the branches should get the least number. Now have a look over here. Tell me at which locants the branches are present. I am not first considering which branches. I am only just telling you to just consider the numbers where the branches are present. So 1 2 3 4th has a branch, 5th has a branch, 6th has a branch, and 7th has a branch. So if you go for the total, so this is 9, this is 15, this is 22. Okay, now go from this side. So again 1 2 3 4 5 6 7. Now here, from here also the numbers are same, means what you can say, the locants are coming same. Now there is a sub rule. Now if the locants are coming same, if the locant numbers or the sum of the total locant numbers is same, then you have to choose from that end or from that branch which is alphabetically coming first. Now this is 1 methyl 1 ethyl, this is 1 butyl, you can say 1 butyl or butyl, simply N-butyl. This is 1 methyl 1 propyl, this is ethyl, so this is E over here. The name of this branch is E. The name of this branch is 1 butyl because the first carbon is attached to the parent chain. So I will write it as 1 butyl. This is 1 methyl propyl. So this branch would be named as 1 methyl propyl. The parent chain carbon is this. To this is the carbon which is attached. So from there longest chain 3. So 1 methyl 1 propyl. And this is 1 methyl ethyl. This is 1 methyl ethyl. Now just have a look at the names E, B, M and M. So alphabetically कौन आएगा पहले? Butyl. So you have to go from this side because butyl is getting the least number. 1 2 3 4 5 1 6 7 8 9 10. So 1 2 3 4 5. So from this side 5 is going to this one. From this side 5 is going to the butyl one. So that is the least which the locant I can give to butyl. So simple hai, you have to go from this side only. 1 2 3 4 5 6 7 8 9 and this is 10. So here I have taken almost all rules into consideration in one single example. Now the main thing is to write the names now. So alphabetically you can see B, then followed by E. This was 1-methyl propyl. This was 1-methyl ethyl. Now have a look over here also. There is one more thing. So now we have to write these 4 substituents in alphabetical order. So have a look. First will be the butyl one. So this will be 5-butyl. You could have written also butyl also, but I am writing it 1-butyl simply because the 5th carbon of the parent chain is attached to the 1st carbon of that butyl. Followed by ethyl. So it should be 4-ethyl. One thing is remaining. The first letter should be capital. So it 5-butyl. You can write as butyl or 1-butyl. Would make no difference at all. 5-1-butyl, 4-ethyl. Now have a look over here. This branch is also 1-methyl. This branch is also 1. So look at the next letter, ethyl and propyl. So who comes first, E or P? So E. So you have to name this one. So that is at 7th. So the name goes as 1-methyl ethyl. Okay. Again parenthesis, and finally we'll be naming this. So 6. It will be 1-methyl propyl. And finally, the longest chain, that is decane. Finally, so this is how you need to name the chains. So I have taken enough examples for alkanes. Hope so you got this. Okay. So these are easy marks. Little bit of practice can make it look very easy. Okay, so in this way you have to write BEM. Now this is also 1-methyl, 1-methyl. So look at the next one, propyl, and this is ethyl. So go for E. So in this way we can name this. Hope so all of you have got this. We'll see few examples of cyclo and we'll end this session. So hope so alkanes are quite, what you can say, you understood it very well, and now on this foundation we can work on the further functional groups and the IUPAC naming of those. So once you know how to name an alkane, it's almost, what you can say, when you do a next functional group, it's almost 90% work is done. Only that 10% or 5%, some 95% work is done. Only that 5 to 10% change in every functional group you need to understand. So let's see some cyclo compounds also. So here also I am taking a little bit of difficult example only. So suppose this is an example and I want to give an IUPAC name to this one. Now rule number 1, we have to see the longest chain. Now here you can see the aliphatic chain, the longest chain is 3, here it is 1, here is 2, but the ring has 6 carbons in the ring, obviously. So obviously that will be considered as the parent chain. So this surely will be written as cyclohexane. Rule number 2, we have to number it now. Now have a look over here. I can number it 1, 2, 3, 3. Means if I just see on which locant the branches are present, it's 1 and 3 or 1 and 3. Now from which end I should number it? So you have to follow the lowest locant rule. So if I put 1 over here, 2 and 3, so look at the locants, they are at 1, 1 and 3, so total comes as 5. But instead, suppose if I make this as 1 and this as 3, then this locant number will be 1, 3, 3, that rounds up to 7. So add करना है, simple. So इससे total ज़्यादा रहे and we want the lowest locant rule. So remember, this will be the first one and this will be the third one. Hope so everyone has got this. Okay. Now you have to just number it in, write it in alphabetical order. This is ethyl. This is 1-methyl, 1-ethyl. This is 1-methyl, 1-ethyl, and this is simple substituent methyl. So how to write it? Alphabetical order. So the name goes as 3E capital, the only capital alphabet in the entire name. 3-ethyl followed by, now 1-methyl or methyl. So go for complex one. So it is 1 bracket 1 methyl ethyl. Next 1 methyl. Okay, and finally the answer is cyclohexane. So this is how you need to name them. So I've directly taken an example of complex naming. So if suppose next one, this is the last one, we will see. Obviously, after in the next video, we'll start with the alkenes and alkynes. So in that also, I'll also give you the preference for the functional groups also, and also how to name the IUPAC name in a correct way. Now for alkanes, it was quite simple, just the substituents and the alkane name. Why? Because it doesn't have any functional group. But in case of the other organic compounds where there is a significant functional group, you have some norms to follow. So we'll see in alkenes. So suppose this is an example, and suppose if I take this like this as an example. Now let's do this. Now simple, the longest chain is of 6, this is longest of 4. Okay, as far as, so obviously the main parent will be the ring and this aliphatic will be the substituent. So obviously this is attached to the first carbon of the ring and this is the immediate carbon which is, so the longest chain. Now some students, they will consider this as also branch, but remember this is in continuous form 1 2 3 and this is the branch. So the name goes as 1 bracket 1 methyl propyl bracket close cyclohexane. So there was less space, so I've written it down, or you could have written it straight only. So hope so guys, everyone have understood how to name the IUPAC names for alkenes. So I've just taken off alkenes. From the next video we'll take one functional group in the session. So alkenes would be the next. So let's meet in the next video. Till then guys, hit the like button, subscribe the channel, hit the bell icon for further notification, and also comment on this lecture. Thank you.